Hey guys, my name is Shamar Langran, and today I'm here to bring you a simple tutorial on how to make your very own printed circuit board. Now for this tutorial, you're going to need a few things. First off, you're going to need your very own circuit board. Now, you could find one online, or you can create your own using the appropriate software. What I used to create mine was something called EagleCAD Soft. Next up, you're going to need paper to print your design onto. Now, preferably, you use blue transfer paper. I'm telling you now that the blue transfer paper is a lot easier to use than regular paper, and it will save you a lot of time than the regular paper would use. Next, you're going to need an iron, a drill, a tape, or anything that you could use to secure a piece of paper with. And next you're going to need a solution of hydrogen peroxide and hydrochloric acid, as well as a container. Now for safety purposes, we want gloves and preferably eye protection, because we are going to be working with those chemicals that we previously stated. And next up, we're going to need some soldering iron and some solder, as well as anything that you would use to solder components onto a board. A soldering pump is also advised that you have as well. Now some sandpaper you also need as well. Now preferably you want a very fine grained sandpaper. Nothing too rough that would scratch anything significantly. You want something kind of really fine so that you won't do as much damage with the sandpaper. Next up, you obviously want the components for your PCB, the components that you will be soldering on with your soldering iron. Some scissors are also a great help, and last but not least, you want your copper board. Okay, so first things first, you want to design your circuit board in a respective software. What we use is Eagle or CAD Soft, and then after you have your design, you would want to print it out onto a piece of paper. Now here you have two options. You can either choose to use this piece of paper as is in your fabrication, or you can choose to scan your design on the piece of paper and print it onto blue transfer paper. Now the second option is what I really recommend. I can tell you that the blue transfer paper is a lot easier to work with than the regular paper. It will make your life a lot easier. So after you print out your design, we want to move on to your copper board. And next, what you would like to do is you like to take your sandpaper and clean out your copper board. Now, it is advised that the sandpaper that you use is very fine. If the sandpaper is too rough, it would most likely damage the copper board, and we don't want that. What we want is a fine enough grain so that you can clean the copper board, so that it won't be dirty, so that the etching process and all the processes that we will go through next will happen properly. So sand out your paper properly, sand out your board properly, apologies, and make sure you do that until it has a shiny, chic-like appearance. Now once this is done, attach the paper that we were talking about, whether it's regular paper or your blue transfer paper, and fasten it securely onto your copper board. Now make sure once you fasten or you put these two together that they will not move, because if they move, then your design will most likely mess up. Now once you've made sure that you have securely fastened your paper to your copper board, next you want to press your design. Now you can do this with an iron as I recommended, but there are many other ways to do this. Just make sure that you press or you apply heat to the transfer paper and the copper board so that the design on the paper can then transfer to the copper board. This is what you want. For blue transfer paper, I'd necessarily recommend 15 minutes. That is how long I pressed mine for. However, if you're using regular paper, I recommend that you press for a very long time, as it's not necessarily easy to get this result with a regular paper. However, as I said, blue transfer paper tends to make your life easier. So once you have pressed out your design onto your copper board, you can now move on to the etching process. Now for the etching process, you use a certain solution. Now I would like to advise that you be very careful with the solution because it is acid and it can have negative effects if it comes into contact with your body, your eyes, etc., etc. So the appropriate protective gear is advised. So you place your copper board into the solution, and what you will see happening is that the tracks or the exposed pieces of copper would start to etch out, or you start to see them disappear. Now the amount of time that you leave this board into the solution varies. It depends basically on the strength of your solution. The exact mixture you'll probably see on the screen right about now, as I have forgotten it. But yes, that's what you want to use. And basically when you take out your board from this solution, you want all of the exposed copper to be erased from the board. Now next you wash the board, because as we said, we are working with dangerous chemicals. So you wash the board out and make sure that the acid is no longer reacting with the board. Please, I also advise that you do not leave the board into the solution for too long. So after you have your design that is now etched, your next process is to drill your design. Now, basically the holes that your components must fit into, you have to drill them so that the components can fit into them, obviously. And you want to use a specific type of drill bit. Now, as I said, the type of drill bit that you must use has currently slipped my mind, but you'll probably see the size on the screen right now, as I will probably get it later. Now, with this process, you have to be very careful, as you can damage your board like this by drilling holes where holes are not supposed to be, damaging the tracks, etc., etc. This process here could pretty much cause your entire board to become void. Simply one mistake. So you want to be very accurate here. You want to hold the drill at 90 degrees and make sure that you do not stop while the drill bit is in the board, because that could be a problem. My advice for this process is to be very precise, try to be very accurate as well, as I said, this is a very crucial point in designing your board. Now the last and possibly the most annoying part, in my opinion, is the part where you solder your components onto your board. Now on the screen right now, you're going to see a few little tricks and tips of how to solder correctly. That is pretty much a very good solder joint, as you can see right now, but this is a little bit too little solder, and the latter right here is what happens when you have too much solder. Now, we're not trying to waste solder, and the soldering iron is a component that is very hot, and so I advise that you take great caution when working with the soldering iron, as I have made mistakes like this in the past. If you are not 100% confident in your abilities to use the soldering iron, I advise that you have a professional supervise you, or even have them do it for you, because this process is of course very dangerous. Depending on your soldering iron, it could be very hot, and damages to your skin. Depending on the variant of the burn, it could be sometimes non-reversible. So take great caution when doing this. So my last bit of advice to you is to be very precise when soldering your components. Now, excessive solder on your board can cause short circuits within your board, because connecting the tracks with the ground via the solder could, of course, as I said, cause short circuits within your component. And of course we don't want that, because short circuits in your board could render your board completely useless or inoperable. Alright, so after this is completed, you have successfully, hopefully successfully, made your very own printed circuit board. I would like to congratulate you if you've made it this far, and I'd also like to give thanks to the lecturers at TAMCC for helping me with this project. I would not have been able to get all this knowledge if it was not for them. In the description, as well as on the screen hopefully right now, you will see a link to their website, as well as Eagle and all the softwares that I use to complete this project. I'd like to thank you all for watching, and hopefully subscribe for more. And until next time, goodbye.